topic for today is how to run a T1 on a sample. These are liquid samples. First thing you want to do is put your sample in and shim it, which I've already done. So we're going to start the T1 experiment. In this case, I'll just go to the Relaxation and Rate Experiments and choose T1 from the menu. You can also just type T1 at the command prompt. We'll give it a name, Tom. And auto 0 TMS. At this point, it's asking you whether you want to create a new list or open a list that you've previously made. And if you're running samples over and over again and checking quality control or something like that, maybe you want to run the same exact list over and over again, you would choose open list. If you want to create a new list because you're not sure what the T1 is, in this case, just do create a list. We're just going to use, because we don't know exactly what the T1 is, we want this to go fast, so we'll do 9 delays. As when you want to do more careful experiments, you can choose any number of delays. And then the most important part, what do you think the T1 is going to be? So the sample I'm running is very concentrated. I know that the delay is going to be, or the T1 is going to be around 2 seconds. In a sample that's been degassed and sealed, you might get something that's closer to 10 or 15 seconds. And certain nuclei, if you're doing lithium or cobalt or something, is going to have much different T1s than anything else. So I'm just going to use 2 for my delay. We can go look or edit the list when it's made. The first number up here is the number of experiments that I chose, 9. And then the 9 numbers after it are the exponential function. The first number in the list is 1/10 of the value that I guessed. The last number is 8 times the value, and everything else in between just creates this exponential function. You could edit it at this point. You could change the number of experiments to 10 and put in a delay somewhere, anything you want to do. So we'll continue with the experiment. The smart window in the bottom left-hand corner will always tell you what it's doing. In this case, it's running INV-REC, that's inversion recovery. That's a 180 pulse followed by a delay time, tau, and then a 90-degree pulse to give us the data. So as this runs, we're going to see, this kind of looks like a standard 1D proton experiment. As the experiment continues, you're going to see the peaks change in amplitude as it gets closer to the T1 of that particular resonance. So as we go through, some peaks will get shorter before other ones do, and then they'll recover, and the other ones will get shorter. And so it's an indication, one, that the experiment's working right, but also it's an indication that different resonances within the molecule have different T1 times based on their movement within solution. So if you're doing something really viscous, the solution is going to inhibit the movement of the molecule in solution, whereas if you're doing something really dilute in a non-viscous solvent, the molecule can freely rotate around and stuff. So a lot of it comes down to the molecule you're studying, how big is it, what kind of groups does it have on it, and then also what solvent is it in. So you'll notice here that the peaks on the left, that's the benzene ring, they've gotten a little bit smaller, but the peaks on the right, the methylenes and methyl, have gotten smaller faster. That's an indication that their T1 time is faster. They have a shorter T1 time. By the way, when we put in a guess of 2 seconds, the software automatically changes the relaxation delay so that the total time for relaxation delay and acquisition is 10 times that, or 20 seconds. So if you look in that first column of parameters, you can see that 10.92 plus 9.808 is 20 seconds. That's 10 times the value of the guess that I gave it. What's added in there, the tau time, the numbers that you see over in the smart window, those are added to each experiment. So each experiment starts out at 20 seconds and then gets a little longer each time. Notice on the screen now, the peaks on the right are much larger. The peaks on the left have gotten much smaller. And then All of them will start to recover now, and we'll see that toward the end here, experiment 8, experiment 9, it's almost going to look like a 1D experiment is being done. When the experiment finishes, the data is automatically processed. There may be some phasing you have to do or a few other maneuvers, but in general, the T1 experiment auto processes so that you can see the spectra. You still have to do the workup to get the T2 or the T1 data. So notice in the smart window it started experiment 9. The delay is 16, so it waits 9 seconds, pulses 180 degrees, waits 16 seconds, which is much longer than the expected T1. So it should fully relax, and then it does a normal experiment. So when we see the results of this last experiment, it'll look like just a normal 1D proton experiment. And like I said, when it finishes that one, you'll see the data process. So when the data automatically processes for a T1, this box comes up allowing you to put in a little bit of line broadening, which will just reduce the noise. However, it does also fatten the peaks a little bit. So for proton, I usually put in 0, and then we'll see all the data. So what we want to look at here is, these are 9 experiments. Let's look at experiment 4. Notice the vertical line there. 5 and 6. So in experiment 4, all the peaks are still inverted. In experiment 5, the methylenes and methyls are right side up. The benzene ring peaks are still inverted, and then in the top one. So what that tells us is the methylenes and methyl have shorter T1s than the benzene ring proton. So let's work this up a little bit. It's pretty easy. Zoom in on a peak and zoom in like you were going to integrate it. You're going to just do a 4-step procedure. First step, zoom in on a resonance. You can type stack plot to see that they're all there. Second step, type GR, get relaxation data. It basically just integrated all 9 spectra in the area that's on the screen. We're going to type DR, like display relaxation data. And what you get is you get the fit function that it's going to use, but not fit yet, and then all the data points in this nice exponential function. And then finally, you can use, under the fit pull-down menu, notice you can just type the letter O or click right there, and then it'll fit. And you can look, the T1 down in the bottom right-hand corner here, it listed as 2 seconds. Okay, let's do another peak. We'll do the methyl here and see what that looks like. So GR, DR, O, that is 2.28. So a little bit longer T1, and then finally, let's look over at one of these benzene ring. Those we know were much longer T1s, just the way they looked in the spectrum. So GR, display relaxation, or get relaxation data, DR, display relaxation data. Notice that the points on the screen are much flatter than in the other one, so we will optimize those. And notice that the T1 in the bottom right-hand corner is 3.79 seconds. Nutshell. Thanks.